Last thing that I want to look at before we do one example of putting some strategies together, and then we'll do today's quiz. But first, let's take a look at this one. This gives you an equation, v squared plus 8v plus 12 equals 0, and doesn't ask you to factor, it asks you to solve this equation. Find out what is the value of v, or what are the values of v, for which this equation is true. So what was your approach? What's the first thing you did? So when you're looking at this equation, your first thought was, I should try to factor this polynomial. And factoring this polynomial involved finding a pair of numbers which multiply together to 12 and also add to 8. And that led you to 6 and 2, positive 6. So this is going to give me 6v, and positive 2 is going to give me 2v. Sure enough, if I were to do out the multiplication in this lattice, I would get back to v squared plus 8v plus 12. But in this problem, factoring is not an end unto itself, it's a means to an end. We use factoring as a tool because what can I do now that helps me to solve this equation? What was the whole point, remember, of factoring?
Solve for v.
We can solve for v. How? What's my next step?
Subtracting 6 and then subtracting 2.
Right. Actually, before I do that step, I need to understand why it is that I can subtract 6 and 2. I need to actually separate those two factors from one another. This, again, is the step that if you're taking a victory lap over doing the factoring correctly, sometimes people during their victory lap forget that there's more work to do. Right? In this problem, we haven't finished unless we've solved for v, gotten the values of v which make this thing true. So that involves splitting this equation into two simpler equations. V plus 6 is equal to 0 on the one hand, and v plus 2 is equal to 0 on the other. And now we can use what you just said, subtract 6 from both sides in this equation, and subtract 2 from both sides in this equation. And that gives us our two solutions. So the whole raison d'etre of factoring is that it allows us to do this. The whole reason we care about factoring is so that we can now solve this equation, which we would not have been able to just by reversing the order of operations. Now, why I wanted to talk at more length about this example is also that this splitting step relies on the zero factor property. And the zero factor property is something that only holds for the number 0. In other words, the only reason that this worked was because this number right here was a 0 on the other side. If this number were not a 0, then this argument doesn't work at all. For example, if the right-hand side of this equation were, so let's say the right-hand side of this equation were not 0, but instead something like -3. So let's imagine that this were our problem. And I look at the left-hand side and say, oh, I know how to factor that, plus 6, plus 2. And then I try and split this equation into two pieces. And often when I see students trying this, they'll keep -3 on that side. Let's just play this out. -3 here, -3 there. We'll subtract 6 from the one on the left. We'll subtract 2 from the one on the right. It's going to give me two, what we think are answers. -3 minus 6, -9. -3 minus 2, -5. And it looks like we're done. Well, let's plug those values back into our original equation and check them. One of the quickest ways to my heart as a grader is to show me on your quiz problem, your exam problem, that you're checking your own work. That's the kind of thing that increasingly I've been giving exemplary marks to in this class. So let's engage in that process. Let's just check, let's say this answer, v equals -5. Let's plug it back into this equation. V squared plus 8v plus 12. And I want to know whether that's equal to -3. For v equals -5, so I'll plug -5 in here in parentheses for my v's. Write the rest of my equation around it. And then simplify that expression. -5, the quantity squared. 8 times -5 plus 12. 25 minus 40 is -15. Is it? -15 plus 12. -15 plus 12 Uh-oh. Interesting. So -5 actually seems to work in this question. I'll be honest, I didn't anticipate that, but we got lucky. Let's check the other answer. Let's check -9. Math is still full of surprises, no matter how long you do it. It's always waiting there to catch you off guard. All right, -9 squared, that's 81. 8 times -9, -72. And 81 minus 72 is +9. +9 plus 12 is 21. Ah, there we go. So the answer -9 does not, in fact, check out. So clearly there is something that's different about trying to split this equation that had a -3 on the other side compared to the equation which had a 0 on the other side. And the reason is that there are, in fact, a lot of different possible pairs of numbers, pairs of real numbers, which multiply together and give you -3. One such pair is -3 and +1, but another might be -2/3 and +6. No, +9. Wait, -2/3. +6? No. Anyway. So there's a bunch. My brain is rolling over on me right now. But there's infinitely many different pairs of real numbers which multiply together to give me -3. We can't say anything about any individual one of them based on some fictitious zero-factor property. So the short story here is that if we have an equation which doesn't have a 0 on the other side, we shouldn't think of factoring as a first step. Instead, here's how I'd recommend going about a problem like this one. My first priority should be to make one side of this equation 0. So don't factor first until or unless one side of this equation is 0. So how would I make this -3 in this equation into a 0 so that then it would be a good idea to factor? How can I make this right-hand side 0? Why not just add 3 to it? Adding 3 to -3 is going to give me a 0. But if I add 3 on the right-hand side of this equation, what else does that compel me to do? Add 3 on the other side. I'm going to write that underneath its like term, right there, so that now I know that my new equation, v squared plus 8v, has a constant term of 15, not 12. And so now that I have a 0 on this right-hand side, now it's a good time to factor. So now, a 0 on this side means now is a good idea to factor. Because now how does my factorization change based on the fact that now I have plus 15 here instead of plus 12? What's the pair of numbers that I need now? Not 6 and 2 anymore. Instead, what? Pair of numbers which multiply together to give me 15 and add together to give me 8? 3 and 5. Plus 3, plus 5, 3v, 5v. V plus 3, v plus 5. Split it into 2 pieces. Solve each one of the simpler pieces. Now we can see why that -5 that we got before still magically works, because it actually still ends up being one of the factors in this expression, but the other factor is now -3, not -9. So, moral of this story is factoring helps us to solve an equation, but only when the other side of that equation is 0. And so if an equation comes to you that is not set up in that way, it's your first priority to make it be set up in that way. Add or subtract to both sides of the equation, whatever you need to, in order to kill off everything that's on one side of it, so that the only thing that's left on that side is 0, and that's your clue that it's a good time to factor.